guys, welcome back to 100 Days Machine Learning Crash Course. Today we want to talk about Matplotlib package in Python and introduce some new ways to plot different data with Matplotlib, and maybe an introduction to Seaborn, because these two packages are too important for working with data. So I decided to introduce you to them to actually have some break between theoretical stuff of Bayesian networks and these kind of things that maybe they are a little hard and theoretical. So I put this session in here. Okay. So for work with Matplotlib, first you could import matplotlib.pyplot as PLT. Then if you're working in Jupyter Notebook and if you want to see your plots online, you could use Matplotlib inline in here. In this case, when you want to plot, you don't need to put plt.show. You don't need this, but if you are not in Jupyter Notebook, you don't need this, and you should use plt.show. Okay, and let's import numpy as mp. Now we could create some data. Okay, now we have X and Y in here. Okay, you probably know the basic plot option of Matplotlib, which is plt.plot of X and Y. In here you could see the plot of X and Y. If you want to set some labels, you could actually use plt.plot of X and Y. Then for X label you could use X label. Let's call it X label or anything you want. And in here we use Y label. And also you could use title. In here. Okay, if you run this, you will see now you have X label, Y label, and your title in here. Okay, sometimes you want to plot some different plots in one figure. For this you could use plt.subplot. So when you use subplot, the first argument is number of rows, then number of columns, then number of the plot that you want to plot that now. So if I write plt.subplot 1 to 1, it means that I want to have one row and two columns. Then in this section, which I chose the first section of this 1 by 2 subplot, I could plot X and Y with red color in here. We will talk about the colors later on. And in the second part, 1, 2, the second, I want to plot, let's say, Y and X with green color. Okay, if I run that, you will see that now I have two plots in one figure. So this is one way to plot different shapes in one figure. Okay, so this is the classic and non-object oriented method to draw plots, but there's a better way to do plotting in MATLAB, in Matplotlib, which you could use, and it is so much more readable and customizable for you. So the way in, so it is better way for plotting. Okay, in this way first you should create a figure. So let's say we call it fig. It is equal to plt.figure. Okay, if you run that, you will see that you just have a figure in here. Okay, now we want to add some axis to this figure. So let's say axis is equal to fig dot add axis, and now in here we put left, bottom, width and height. Don't worry about this, you will now get this. What is that? So if I run that, you will see now I have a figure. In this figure I have two axes, and the first number is actually the left. So it means that we want to have 10% from the left of our figure. Then this is the bottom, so we want to have 10% of the whole height distance from here, and this is width and height. So if I make it now, you will see that I have a different axis in here. Or if I put that in here, then I will have different position for my axis. Okay, now let's okay, now we could plot our data on the axis. So for plotting data, you could use axis dot plot x and y. If I run that, you could see now I will have the same result. And for axis, you could use to add a label, you could use set x label and for the same for y-axis label and for title. If you run that, you will see that you will have a nice figure. Okay, so this is more customizable. Let's see how. So let's say I have a figure again. Now easily you could add two axes to this figure. So if I put fig that x add axis in here, I put for the second one, let's call it axis 1, and for axis 2 I could use, let's say, 0.2, 0.5, 0.4 and 0.3. Okay, if now I see that, you will see that this is the first axis. Now this is the second axis. Okay, now I could plot the data on each one. So let's say we want the red one in the first axis, and I want this in the second axis. Now you could see that I have two different plots in the same figure. So you could see that this actual method for plotting is more powerful than the classic method. Okay, sometimes also you want to have subplots in the new way. So for creating subplots, you could use fig and axis is equal to the method of subplots and the first argument is number of rows. So let's say we want to have 3 number of rows, and the second argument is number of columns. Let's say we want 3. If you run that, you will see that you will have 3 by 3 figures or plots. Now, but let's say now we want to have one row and 2 columns. Okay, how should we plot on these different axes? If we print the axis, you will see that it is a list of 2 different axes. So you could plot on this axis with, the first way is to just select your desired axis and then use plot. The second way, which is sometimes more useful, is that use iterator to iterate over that list, because axis is a list. So I could use for x and axis x dot plot x and y. So you could see that now I have I plotted this data with iterating on the axis. Okay, now sometimes you want to have a bigger figure or smaller one. How should we adjust the size of the figure? For adjusting the size, you could use fig size. And so let's say we want to have a 4 by 5 inches figure. So if I run that, and let's add some axis to this figure to see that. Okay, now you will see that I have 4 inches by 5 inches figure. If you want a bigger figure or different figure size, you could change the figure size in the argument of figure and plot your data in here. Okay, now let's say you want to save your figure in, so you plot this and now you want to save this data. For saving, you could use savefig. So if you use savefig, now the argument of this is the name that you want to save. If let's say it is my fig, and it could be PNG or JPG or some PDF. So let's say it is PNG, and also you could use the DPI argument to specify the quality of saved image. Okay, so or you could use the default DPI of Matplotlib. So now I could run that and my figure will save in the directory. Okay, now let's create again a figure and add access to this figure. Now let's plot x and x squared and x and x cubed. Okay, if you run that, you will see so this is x squared and this is x cubed. Okay, now let's say you want to specify the name of these in your figure. For doing this, you could use legend. So first you should pass some label to your plot. So I named this plot x squared, and for this I will name it x cubed. Now in here you could use access.legend. Okay, now you could see that I have this legend in here. So for x cubed it is orange one and the blue one is x squared. Okay, so sometimes actually legends are very useful and important. Okay, now we want to talk about different colors and styles and in general appearance of the plots in Matplotlib. So let's say, so I have the plot in here. Let's do this again very quickly. So plt.figure, I want to add some access. Then I want to plot x and y. Okay, for colors actually you could pass color in here. So for common colors you could write the name of the colors in here, like black if you want black plot, if you want orange or blue or green or something like that. Okay, the second option that maybe you are interested in is use custom color in here. For that you could use actually the hex RGB color code. For RGB hex color code you could search that in Google. And so let's say you want to have something like this color. Now I could when you click on convert you could get the hex color. Now I will copy that in here. Now you could see that I have the same color as this in here. Okay, so we have different ways for specifying color of a plot. The first way is to just using common name colors like green, white, blue, orange, purple, or this kind of names. The second way is that you want a custom color. In that case, you could actually convert that to hex color code and then put it in here. Okay, so let's set this as orange. Now let's say you want to have a thicker line and adjust the line widths. For this, you could actually use line widths. 1 means that this is the default line widths of Matplotlib, but if you want thicker line, you could use 3. If you use 3 now, you have thicker line, or and so on. So you could use line widths to specify the width of the line in here. And there is another method for specifying how much this line that you want to be transparent, and that method is called alpha. So if I use alpha 1, it means that my line is completely visible. If I use 0.5, so it is between 0 and 1. You could use that it is more transparent, and when I am more close to 0, it is more transparent, and for 0 it is completely hidden. Okay, now let's set this to 1 and this to 2. Okay, now let's say you want to have different line styles. So another useful argument is line style. You could have double dot, double dash. If you use double dash, you could see that you have something like this. You could have dash period. So this is dash period style. You could have this line style, and this is the default line style. So now you could use different line styles to specify your plot. The next argument that sometimes is useful is marker. So marker, let's specify that as O. See what is that for having better insight about what is that. Let's put this to 20. Now you could see that when you use marker, actually you mark the data points, your actual data points in here. Now the marker itself has different options. Maybe you want to have, so we have marker face color. To change the face color of marker, you could, so now I have black marker face color, or you could use marker edge color. So this is the edge color of, maybe I put green, so this is the edge color of the markers. And so let's put this red. Okay, and we have marker edge widths to specify the width of edge of marker. You could use 3 or anything that you want. So there are lots of options to customize your plots in Matplotlib. And if you want to have bigger marker, you could use marker size. So let's say you could use 20 to have very big markers in here. Okay, and sometimes you just want to limit your x-axis or y-axis to certain limits. In this case, you could use axis x lim and y lim. So if you use set x lim 0, so let's say I want to have 0 to 3, and for y I want to have 0 to 20. If I run that, now you could see that I have 0 to 3 and 0 to 20 for my y-axis. Okay, now you probably know most of the things about Matplotlib. Also, we will see how to work with Seaborn, because for actually plotting histograms and other stuff, Seaborn is more useful. But with Matplotlib itself, you could actually plot histograms and bar plots and this kind of things, but Seaborn is more powerful tool to plot this kind of data. Okay, now we want to talk about Seaborn. Seaborn is actually very useful package for working with for visualizing data sets, and works very well with pandas. So let's create a new notebook in here. Okay, for installing Seaborn, you could just use sudo pip3 install Seaborn. So you could, in this way, you could install Seaborn. Okay, now so in this session we actually want to introduce very little about Seaborn, because Seaborn has lots of capabilities, but we just want to have a quick introduction to Seaborn. So let's import Seaborn as SNS, and also Matplotlib inline. Okay, the first thing, okay, let's load some data. SNS has, or Seaborn has, some default data set that is called tips. If we print the head, you could see that it is a data set for actual tips based on different data. Okay, the first thing that is useful is this plot. So if you use this plot of tips, so In here you could pass the variable that we want to get the histogram of that. So for example, let's say we want to have total bill histogram in here. Now you could see that we have the histogram. If you don't want this line, you could use KD equal to false. In this case, you don't have that kernel density estimation. So let's put it to true, and you could also in here you could specify number of pins in here. So let's say we want 60 number of pins, and you could actually do this manually. If you use very large number of pins, the behavior, you could see that it is a little weird. So you should just find the proper number of pins if you want to apply that manually. Okay, the second thing that is useful for plot the data is joint plot. Joint plot. So it gets X and Y and data. So in here, let's say we want to have total bill, and the Y data is tip, and the data is tips. Okay, if you plot that, now you could see that we have the joint plot of tip and total bill. So it is a 2D distribution of based on tip and total bill, and in here you could see the distribution of total bill. This is the distribution of tip, so this is the 2D distribution of tip and total bill. And also this can take some other arguments like kind. So in here I have scatter type of joint plot. You could use hex. So in hex, when you have darker hex, it means that you have more data in there. Or you could use reg, which is the scatter distribution and the regression line for that. And also you could use KD mode, which is a kernel density estimation mode of that, as you could see. And also, so yeah, that is so useful to see the 2D distribution based on two different data. Sometimes, in fact, in lots of scenarios, that we want to have all of the pair plots. So if we want all of the joint plot, we could use pair plot. So you paste your data in here. Running this maybe takes a little time. If I run that, now you could see that I have total bill tip size in here, total bill tip size in here, and so for the joint plot of total bill based on tip, I have this one. For total bill based on size, I have this one. So this is 2D distributions. And for total bill based on total bill, so because these are the same, I just get the histogram instead of 2D distribution, because we will get a line in here if we plot the total bill based on total bill, and it is meaningless actually. So for diagonal components we have histograms, and in these components we have 2D distributions. And the cool thing about this is that you could use hue based on a categorical variable. So in here, categorical variable, let's say based on sex, we want to separate this data. Okay, now you could see that we separated the data based on sex, which could be male or female, in here, and many of the times it is so useful for us. And also you could use palette to specify, let's say it could be cool warm, that is different color scheme for plotting. So you could actually see more of these palettes, different options in Seaborn documentation. For see the documentation, you could go to the documentation of Seaborn and see the examples. And so in here we have example gallery, and you could use that in here. Okay, so I think this is enough for us for this session, and now you could actually plot lots of things with Matplotlib or with Seaborn. Okay, we will continue our theoretical discussion in the next session. Hope to see you in the next. Bye.